All right. Here is one way you can avoid running the non-parametric version of a t-test of the one sample or the independent t-test or the dependent t-test. This is an argument that can be used for any of those t-tests. And that is, you could argue that even though there's a violation to one of the assumptions, your t-test is robust. All right. And this is a very common argument. You'll see it a lot. People will say, yeah, our data wasn't quite normally distributed, but the t-test is a robust statistic. So what does that mean? As long as the assumptions are not severely violated, the results of the t-test will be about as accurate as they would have been without the violation. So let's say that you run let's say test the assumption of normality. So you do a Shapiro-Wilks and you find out that the Shapiro-Wilks statistic is significant. That means that our data is probably not normally distributed. In other words, you have violated the assumption of normality. All right, so what you could do at this point is just argue my t-test, well, t-test in general, not just yours, the t-test is a robust statistical test, which means the results that I got with the violation are probably going to be no different had I not had the violation, right? In other words, the violation probably didn't change the outcome. Now, there is a problem with using this argument. One is we really have no hard and fast definition for what it means to be severely violated. So that means that no matter how far from normality your data are, you could always say, oh, well, that's not severe, right? If we don't have a standard as to what constitutes a severe violation and what does not, then what stops you from saying, oh, that's not severe? Okay, so that's a problem with using this argument. Now, if you send a paper in to be published, let's say you did an experiment and you want to get it published and you have violated one of the core assumptions for the t-test, you might let's say if you use also the argument, well, my t-test is robust. I keep saying my t-test. T-tests in general are robust. You might get a reviewer who's going to accept that and say, yeah, I agree with that. And then again, you might get a reviewer who says, not so fast. There's a problem with this argument, and it has to do with this here being what does severely violated mean. All right. So your paper could be rejected. Or maybe they'll just say, no, we want you to run the non-parametric equivalent. Then again, you could try it. Maybe it'll be accepted by the reviewers. You don't know until you try. Okay, so again, the problem with the argument that t-tests are robust is that there is no accepted definition of what is considered to be a severe violation. And if you decide that you're going to use the argument, you can, but remember that you're still going to have to report the violation. That is a bare minimum. You can't ignore the violation, claim that t-tests are robust, but not report that you had a violation to whatever it was, normality or whatever. Okay, so very, very bare minimum. Always report the violation. Some reviewers will accept t-test is robust argument and some won't. And if your results are still significant with a non-parametric test, then use it, right? I say we try to avoid using non-parametric tests, and that's because our significant effect could disappear. But go ahead and try the non-parametric equivalent And if your results are still significant, then I would go with this option rather than try this one, because the robust argument might not be accepted and your paper might get rejected or returned for revision. So again, if the non-parametric test, if after you use it you retain your significant result, then just go with that one. That would be the smart thing to do. Now, if you lose your significant effect with this non-parametric test, that's when you hit the delete key, all right? Erase all evidence that you even tried and just fall back on this robust argument.